Sound check 1. Okay, thanks for logging in this morning. We're going to go ahead and get started. And today's topic is solving quadratic equations by factoring. So before we talk about what exactly a quadratic equation is, I just want to show you an example of a problem and talk about how we can change the problem to be like ones we already know how to solve. So this first problem we're going to look at today says solving an equation written in factored form. So remember, we talked about last time and we said that factoring means writing something as a product. So factored form means that it's written as a product. Product means multiply. So if something's written as a product, that would be something like, for example, writing 30 as 5 times 6 is factoring the number 30, writing it as a product. All right, so where do we see a product in this equation? This equation says the quantity 3y plus 4 is being multiplied by the quantity 6 plus y. So we have a product. Now each one of these, 3y plus 4 and 6 plus y, these are two different mystery numbers that are being multiplied together. So if I tell you, hey, I've got these two numbers and I don't know what they are, but I know that if I multiply them together, that the product is 0, what does that tell you about the two mystery numbers? Well, it should tell you that one of them has to be 0, because the only way you can get 0 from a product is if one of the numbers happens to be 0. Right? So 0 could be 5 times 0, it could be 0 times 2. It's something, it could be 0 times 0. Okay, but one of the numbers has to be 0. So this is called the zero product property or the zero factor property. And we use it a lot of times to solve equations where we have a product. So in this case, we know that either 3y plus 4 is equal to 0, or, let me get a darker color here, 6 plus y is equal to 0. One of those two has to be true in order that when we multiply those two mystery numbers together, we get 0. So to say that their product is 0 is equivalent to saying that either this one equals 0 or this one equals 0. So what I've done here is I've taken a more complicated equation and I've rewritten it in the form of two simpler linear equations which we know how to solve. That's what we like to do in algebra. We like to take a more complicated situation and compare it to previously known situations to simplify our work. So in this case, if I solve 3y plus 4 equals 0, all that involves is isolating the y. So I would subtract 4 from both sides, divide both sides by 3, and we would get y equals negative 4/3. Or in this case, we could subtract 6 from both sides, and we would get y equals negative 6. Now, notice that y can't be negative 4/3 and negative 6 at the same time. This is why the word or is important conceptually in this problem, because it can be one solution or the other, but not both simultaneously. But we do have two solutions in our solution set that are possible: negative 4/3 or negative 6. I noticed that our stream is a little bit choppy today. Let's see. So if you're experiencing some buffering, I do apologize. Remember, I am recording this, and you can always watch the recorded version later if it gets really bad for you. But sometimes it happens, and sometimes it doesn't. It's hard for me to predict that. But in any case, if you have any questions as the stream continues, please go ahead and type them into the chat bar. If you're just joining us, please type your name and your class and the days and times into the chat bar to get your bonus points, or your alias if you prefer not to use your name and you can just tell me later. Okay, we're going to continue then. And you see how in the first problem, this equation could have been given to us in a different form. I'm going to shrink this a little bit. So the equation we had in the first problem was 3y plus 4 times 6 plus y equals 0. If you FOIL that out, which we would never do to solve the problem because that would just give us more work than separating it into two separate factors that equal to 0. But if we were to multiply it out, what would it look like? So first times first would give us 18y. Outer times outer would give us 3y squared. Inner times inner would give us 24. And last times last would give us 4y. Right? I'm doing the FOILing process. That's how you multiply binomials. And so we would get 3y squared, combining like terms, 18y and 4y would be 22y plus 24 equals 0. This is what's called a quadratic equation. Quadratic equation is any equation of the form ax squared plus bx plus c equals 0. Very frequently, quadratic equations can be solved by writing the quadratic polynomial in a factored form. So if I had been given this equation, 3y squared plus 22y plus 24, I would rewrite it as a product. I would factor it out. That way I can use the process of using the zero factor property. So let's look at this next problem and see if we can apply the skills we learned last time about factoring polynomials of this form. So we have x squared minus 6x minus 7 equals 0. Okay, and we want to solve that equation. Recognize that that does fit the pattern that we just discussed of a quadratic equation. Ax squared plus bx plus c equals 0. Okay, there are actually several techniques for solving a quadratic equation, and by the end of this semester we will have covered them, but at this point what I'd like to use is the factoring technique. So we're going to factor the polynomial x squared minus 6x minus 7. Remember that we in class used what I called the AC method for factoring trinomials. In this case, the coefficient is 1 in front of the x squared, even though it's not written. I'm not sure if this is big enough, if you can see it. Okay. Okay, so A is 1 and C is -7. So the AC method tells us to multiply A times C, which would be AC equals -7. And then we're going to look for factors of -7 that add up to B, which in this case is the coefficient of x is -6. So we're looking for factors of -7 that add up to -6. Okay, now you might see it automatically, or you might end up having to list out all the factors. In this case, listing the factors isn't really that hard because 7 is a prime number. So 1 times 7 is 7. In order to get a -7, one of these two, the 1 or the 7, has to be negative. In order to add up to a -6, it would need to be the larger one that's negative. So the factors we're looking for are 1 and -7. Now in class, we talked about using these two numbers to split the middle term. But we said that if the leading coefficient was a 1, you could actually just skip to the end and you could say, okay, this guy is going to factor into x plus 1 times x minus 7 equals 0. So that's what I'm going to do. I'm going to not do the splitting the middle term part. I'm just going to skip to the end, use the shortcut. All right, you could check by foiling that out that it does equal x squared minus 6x minus 7. So now that we have it in factored form, we can use the zero factor property, right? We have two mystery numbers, x plus 1 and x minus 7. They're being multiplied to give us 0, so that means one of them has to be 0. So we're going to write either x plus 1 equals 0 or x minus 7 equals 0. All right, if x plus 1 is 0, that would mean x would be -1. If x minus 7 is 0, that would mean x would have to be 7. So our solution set contains -1 and 7. All right, I just want to remind you as I get to the end of this problem that if you have any questions about any particular part, you should not be shy about typing it into the chat bar. There is a little bit of a lag between when I speak and when you hear me and vice versa, so it could take a minute for you to see a response, but I will get to your question, so don't be shy. Okay. So when you're given a quadratic equation, something of the form ax squared plus bx plus c equals 0, and so you see that you have a trinomial here, you're going to use the factoring techniques that we've discussed in class, or if you have another way of factoring, in this case a trinomial, you can use that too. We just did the AC method because that's the one I picked for class. All right. Let's go on to the next equation. So this one looks quite a bit different from the other one. One of the differences you'll see between this one and the last one is we don't have a 0 on one side. So having a 0 on one side is referred to as having it in standard form. So I'm going to go ahead and subtract the 13v over to the other side in order to get 0 on the right, and now we have it in standard form. Remember, this 0 is important because the zero factor property helps us solve equations, and in order to have that ability to use that property, you have to have a product that's set equal to 0. All right, now looking at the left side, notice that it doesn't really match up with the ax squared plus bx plus c pattern that we're looking for. We have a squared term and we have a linear term. In other words, we have the v squared that matches up with ax squared, and we have the -13v that matches up with bx, but we don't have a plus c here. You could think of the plus c as being 0, but the the more important thing is to recognize that if it's a squared, it's still a quadratic, and you still might be able to solve it by factoring, but we're not going to use the AC method to factor when there's no C here. But actually, this is even easier because we can factor out a GCF. What's in common to those two terms, v squared and negative 13v? Can anyone type into the chat bar what's in common between v squared and negative 13v, those two separate terms? Remember, terms are things separated by a plus or a minus. What factor do those two terms have in common? Very good, Christina, a v. So if I factor a v out, we get v times v minus 13 equals 0. All right, so now we have two mystery numbers being multiplied together equal to 0, like we had before. So we're going to use the zero factor principle, and we're going to say either v is equal to 0 or v minus 13 is equal to 0. And I really should write the word or here. Okay, so nothing to solve on the left, v is 0. Adding 13 to both sides, we get v equals 13. So we have two solutions, 0 or 13. Okay, so factoring out a GCF is something you should always check for to see if it's possible. Now, as I've been solving these equations, I've been a little bit remiss. I should have been emphasizing, what does it mean to solve an equation? When you solve an equation, when you find a solution, what you're doing is you're finding two values in this case. Could be one value, could be three values, depends on the equation. But we're finding values of the variable that make the original equation true. Right, so for, oops, how did that happen? Okay. So if we were to plug 0 or 13 back into the original equation, it should give us a true statement. So let's just check. So if I plug 0 in, I have 0 squared equals, I'm putting a question mark because I'm not sure if I got a right answer. 0 squared equals 13 times 0, which means 0 equals 0, which is true. So 0 worked. And 13 squared equals 13 times 13 means 169 equals 169. So that one worked. So we did in fact find two solutions that make that one statement true. Whenever you're solving quadratic equations, equations with a degree of 2, highest power on the variable being a 2, it's possible to have no solutions, one solution, or two solutions. You'll never have more than two. All right, let's look at another example of a quadratic equation. You'll notice this is from Alex. It says a quadratic equation needing simplification. So this one is kind of messy to start with. In fact, you might not even be sure when you look at it at first. You might think it's probably a quadratic, but not sure until we combine like terms and see if it still has an x squared when we're done. But it looks like it's probably going to be a quadratic. Again, we want standard form, which just basically means a 0 on one side. Okay, so in order to achieve that, we're going to, first of all, multiply through any parentheses. In this case, we're going to square out the x plus 6, and then we'll see about going from there. So x plus 6 quantity squared is the same as multiplying x plus 6 times x plus 6. If you FOIL that out, notice that you get first times first is x squared, outer times outer is 6x, inner times inner is also 6x, and last times last is 36. Common error to avoid is people want to write x squared plus 6 squared. They think they can just square each part, and that's not true because they'd be forgetting about those two 6x's in the middle. So the left side of this equation is really x squared plus 12x plus 36. We still have the right side though. Let's write it down. Equals 2x squared plus 17x plus 22. And we want to get this into standard form, which means 0 on one side. 0 on one side. Okay, so you could subtract 2x squared over to the left, but that's going to give you a negative leading coefficient. I prefer to keep the leading coefficient positive because it makes it easier to factor. So I'm going to subtract x squared from both sides. I'm going to subtract 12x from both sides. And I'm going to subtract 36 from both sides. That will leave me with a 0 on the left. And on the right, we're going to have x squared plus 5x minus 14. Okay? Make sure you see where that is coming from. And again, type into the chat bar if you need me to repeat anything. Oh, good question. So you asked if you did 6 times 6 to get 36, 6 times 6 to get 36, why do you still need the 6x and the 6x? Well, remember, when you multiply x plus 6 times x plus 6, what you're really doing is you're multiplying the x times the x plus 6, and you're multiplying the 6 times the x plus 6. Each term in the first pair has to be multiplied by each term in the second pair. So when I multiplied the 6 times the 6, that was just one step. I also had to multiply the x times the x times the 6, and the 6 times the x. We have a lot of distributing through to do. So we get x squared plus 6x plus 6x plus 36. Each term in the first x plus 6 multiplied by each term in the second. Now you may have heard that referred to as foiling, which means you do first, outer, inner, last. First times first refers to the x being multiplied by the x. Okay, so that's giving us the x squared. And then FOIL, we did the f, first times first. Outer times outer is referring to this x, the first x, and the last 6, so that would be 6x. Inner times inner refers to the two inner terms, this 6 and this x, so 6x again. And then last times last, oh, we did inner already. Last times last is going to be this 6 times this 6, which gives us the 36. So whether you think of it as a double distributing or you think of it as FOIL, either way, you're going to get 4 terms. Okay, any other questions? Okay, it's very important to be able to FOIL. You can always look up YouTube videos on FOIL, F-O-I-L. You can look up YouTube videos on multiplying a binomial times a binomial. And of course, you're welcome to use your Broward College resources, such as coming to my office, going to the library on the second floor with the tutors, and even there's online tutoring using a link in your D2L called BrainFuse. The reason I subtracted them is I need this form. I need to have 0 equal something. So how do I get 0 on one side of the equation? I need to subtract all the terms, but whatever I do on one side, I have to do on the other side. Now, why do I need a 0? because I need it to look like this. A factored form equal to 0, so I can separate it into two separate equations. See, quadratic equations are not like the linear equations you're used to solving. You can't just isolate the x because there's two x terms, and they're not like terms. You can't combine them. So we have to come up with another way, and the way that we use is to factor. So now that we have it in standard form, the next step would be to factor. And notice that it is a quadratic. It's got the form that ax squared plus bx plus c. And we can use the AC method. Now the a in this case is just a 1. It's just not written. So multiplying a times c means multiplying 1 times negative 14, which gives you negative 14. And b is equal to 5. So we're looking for factors of negative 14 that sum up or add up to 5. So can anyone tell me two numbers that multiply to give you a negative 14 but add up to a positive 5? Can you type two numbers into the chat bar that multiply to give you negative 14 but add up to 5? Sometimes the two numbers will just pop in your head, and then other times, for whatever reason, there's a larger number or whatever, it won't. So just start listing factors and you'll come across them. So here, factors of 14 are 1 and 14, 2 and 7, and that's it. There's no other factors that multiply to give you 14. So now, to get negative 14, one of these numbers has to be negative, but we want the sum to be a positive, so you want the larger number to be positive. So we're going to say, what if we had negative 1 times positive 14? Well, that would add up to positive 13, which is not what we want. But if you added negative 2 to positive 7, very good, Christina, then you would get positive 5. So we're going to use negative 2 and positive 7. Now, if the coefficient in front of the x squared was not a 1, we would use that to split the middle term. But since it's a 1, we can use our shortcut. This is going to be 0 equals x minus 2, right? One of the factors we found was negative 2, times x plus 7. All right, so far so good. We have now got we've accomplished something very important, and that is that we have written our original equation in standard form and then factored version of standard form. So now we can apply the zero factor property, which says that either x minus 2 is equal to 0 or x plus 7 is equal to 0, right? These are two mystery numbers being multiplied together. Their product is 0, and the only way that can happen is if either x minus 2 is 0 or x plus 7 is 0. All right, so if x minus 2 is 0, that would mean x is equal to 2. Or if x plus 7 is 0, that would mean x is equal to negative 7. So those are your two solutions. I'm not going to check them because I'm trying to save time, but if you plugged them back into the original equation, you would see that each one of these individually satisfies the equation, makes a true statement. Okay. All right. So again, as I'm going, don't worry about, interrupting. You won't be interrupting at all if you type a question in the chat bar. I'm sure other people have the same question. Okay. So let's move on to the next problem then. All right. So we saw in the previous problem the basic idea or steps for solving a quadratic equation is number 1, we're going to get it in standard form. Getting in standard form just means getting 0 on one side. Okay, of course you want to combine any like terms, so you might have to multiply through some parentheses before you can do that. But the basic idea is you want 0 equals ax squared plus bx plus c, something of that format. Step 2, we're going to factor. Okay, you can try factoring out a GCF first, but generally it's going to be a trinomial, and we're going to use our AC method if you have all 3 terms, or take out a GCF if you only have 2 terms. We're going to talk about some other things that happen with 2 terms in the next sessions, but those are the 2 that we've looked at so far. Okay, and then you're going to, step 3, you're going to use the 0 factor property, meaning set each factor to 0. Okay, so let's look at this problem here. 9x squared equals negative 30x minus 25. So this fits the pattern of a quadratic equation because we have a power of 2 on the x. So we know we can't just get x by itself. We have to use this 3-step process. So go ahead and get it in standard form. You could, I'm going to rewrite the equation here a little larger. 9x squared equals negative 30x minus 25. You could subtract 9x squared over to the right, but then you'll have a negative leading coefficient and you'll have to factor out a negative. So I like to avoid that extra step. So I like to bring the other 2 terms over. So what I mean by that is we're going to add 30x and add 25, and whatever we do to one side, we do to the other side. So that gives us, that keeps the balance of the equation, right? So we have 9x squared plus 30x plus 25 equals 0. Okay. In this problem, we're going to use the AC method. So because we have 3 terms, a 3-term quadratic polynomial, and so we're going to multiply the A, which is 9, times the C, which is 25. So AC, give myself a little more room here. Okay, so AC is going to be 9 times 25, which, let's see, 8 times 25 would be 200, right? So 9 times 25 is 225. So we're looking for factors of 225. Oops. Factors of 225 that add up to B. B is 30. Okay, now those are large numbers, but don't be intimidated. Just because you can't tell just looking at it what the 2 factors are that add up to 30 doesn't mean you should panic. Be organized and systematic about looking at the factors. So what I mean by that is literally start with 1. 1 times 225 would give you 225, but that adds up to 226, so that's not going to work. 2 doesn't divide into 225 evenly because it's not an even number. Does 3 go into 225? Check on your calculator if you're not sure, but yeah, it does. It goes in 75 times, but that adds up to 78, so that's not going to work. No even numbers are going to work if 2 doesn't go in, so we can jump to 5 now. Does 5 go into 225? Yes, it goes in 45 times. That adds up to 50. We're getting closer. Okay, does 7 go into 225? No. Does 9 go into 225? Yeah, we know that one because that was how we got in the first place. 9 times 25 is 225, but that adds up to 34. But we're getting really close now. Okay, does 11 go into 225? No. Does 13 go into 225? Let me check. I'm not sure about that one. Let's see. 225 divide, oops, clear. 225 divided by 13. Nope. Okay, does 15 go into 225? Yes, it does. It goes in 15 times if you check. All right, and 15 plus 15 does add up to 30. So that's how we're going to split the middle term. So that gives us 9x squared plus 15x plus 15x plus 25 equals 0. So see, I haven't changed the equation. I've just written it in a different format. All right, do you remember why we split the middle term? We did that so that we could use grouping. We've turned a trinomial into a 4-term polynomial. We're going to group the pairs and see what they have in common. And by the way, if you can find two numbers that multiply to give you the product of A and C and add up to B, then you know it is going to factor. So when we look for a GCF in each of these two large pairs here, we should find that what's left behind is going to be the same factor. What was the question? Do you always have to find the factors of the first and last number? You always have to find the factors of the product of the first and last number, yes. We refer to the first number, the coefficient of x squared, as a, and we refer to the last number, the constant term that doesn't have an x in it, as c. You multiply those two values together, and you always have to look for factors of those two that add up to the middle number. Okay? All right. So now I'm going to factor out of 9x squared plus 15x. We have a common factor of 3x, and that's going to leave behind 3x plus 5. And then in the other set of parentheses, we have a 5 in common. And notice that also leaves behind a 3x plus 5. That's important. That should happen because we know this is factorable, and these two big terms need to have something in common. So if you find that you did not get the same thing left behind in red there, then you made an error. All right, so go back and check your work. So I'm going to factor out the 3x plus 5, and notice what's left behind in this case. This is a special case. It's 3x plus 5. So really, this trinomial that we started with was what's called a perfect square trinomial. It's equal to 3x plus 5 quantity squared. Now, the reason I'm mentioning that, you can use the regular process that we just went through. It's very reliable, and it will get you where you need to go. But if at the beginning of the factoring process you notice that A is a perfect square and C is a perfect square, you can always check to see if you happen to have a perfect square trinomial. And all you have to do to check for a perfect square trinomial is you say, okay, what's the square root of 9? 3. So you write 3x. What's the square root of 25? 5. And then you multiply that times itself and see if you get the right trinomial. And if you do, you don't have to go through the whole factoring process. Okay, that only works when you happen to notice that you have perfect squares for A and C. And what you're really checking is if you multiply 3x plus 5 times itself, do you get that middle term of 30x, which you will. But anyway, if you don't notice that, it doesn't hurt anything to go through the AC process. It's just a lot of the times these perfect square problems have big numbers, so that would save you a little bit of work. Okay, so anyway, so if we just have one number squared equal to 0, then that number, 3x plus 5, must be 0. So just set that one factor equal to 0. We're going to solve for x, so subtract 5 from both sides. You get 3x equals negative 5. And dividing both sides by 3, you get x equals negative 5/3. This is the only solution. So with a quadratic equation, remember I said you could get 0 solutions, 1 solution, or 2 solutions. In this case, we got just 1 solution. Okay, if you have any questions, just type it into the chat bar. All right, we're going to do one more problem today. This one is a word problem that involves solving a quadratic equation. It says finding the perimeter or area of a rectangle given one of these values. Actually, I think this one doesn't involve a quadratic equation. I take that back. Let's take a look. The length of a rectangle is 3 times the width. So the length of a rectangle, anytime a word problem mentions a geometric shape, draw it, right? Actually, I can do a prettier rectangle than that. Oops. Let's do this. There we go. Okay, so then you start labeling whatever information it tells you. It tells you that the length is 3 times the width. So it's describing the length by telling you how it relates to the width. So if that's the case, then you should let the width be your variable, x or w. I'm going to use w. So here's w. And then the length you're going to write as a variation, an expression with a w in it. In this case, 3 times w. Okay. Now, in order to work this problem, you have to remember how to find a perimeter and how to find an area. Perimeter is just adding up all the sides, the lengths of the sides. So let's label all the sides. So we have w, 3w, w, and 3w. And the perimeter, P, is going to be w plus 3w plus 3w. So if you add up all of those, we have 1w, 1w, 3w, 3w. That adds up to a perimeter of 8w. And they tell us that the perimeter is 56 feet. So 56 equals 8w. And then we're going to solve for w by dividing both sides. This is a linear equation. It's not quadratic. I was wrong. It only turns out to be linear. There's no squared on it, in other words. So we can go ahead and solve by just getting w by itself. So dividing by 8, then we're going to have that 7 is equal to w. And then we have to find our length. But remember, the length is 3w. So 3w would be 7 times 3, which would be 21. So our length is 21, and they're using feet. And our width is 7 feet. But that's not what they asked us for. In some problems, they'll ask you for the dimensions, and that's what you would give them. But in this case, they said find its area. So how do we find area? The area of a rectangle is just the length times the width. So if we have the length and the width, we're going to multiply those together. So in this case, we have the length of 21 feet times the width of 7 feet. The reason I wrote the units in there is just to remind you that when you find area, you end up with square units, because 21 times 7 is 147, and feet times feet gives you feet squared, square feet. So the area of this particular rectangle is 147 square feet. So you're going to have some problems in ALEX where you're expected to understand how to find a perimeter and an area of a rectangle. Okay, so that's all for today. We'll pick up where we've left off right here next class. In the meantime, first of all, if you're watching the recorded version of this, remember you also can post your name, the days and times of your class, and a quotation from the video, and you'll get bonus points. If you watched either the live chat or the recorded version and you find the video helpful, please give it a thumbs up, give it a like. That helps other students to find the video. In between now and the next class, if you have any questions, remember that you can send them to me. You can, for example, take a screenshot of the ALEX problem you're working on and email it to me or Skype me. And you can also go to the Alex Lab, which is on the second floor of the Central Campus Library, behind the elevators. And you can ask at the resource desk if you don't see it, but the door is in the back left corner. You can work on your Alex there and get help. So if you get stuck on a problem, you can, figure it out with some help, and it's going to save you some time. You can also just go to the regular tutor lab. Oh, good question, Christina. She said, what you said about BrainFuse earlier, how do you log into it? And also, it doesn't have the option for intermediate math, only college algebra. So do I just click college algebra? Yes, you can click college algebra and get tutoring for intermediate algebra that way. Yes, absolutely. The way that you get to it, let's see if I can pull it up here. Okay, so if I log into my D2L, I hope I can see it the same way you do. I can't remember. Let's see. Okay, let's go to our classroom. Okay. And here we go. Under the resources tab, let me make this a little bigger. Under the resources tab, it says academic resources and then BrainFuse. So we're going to click on BrainFuse. Okay, we're going to click on live tutoring. Oops, I think this is different. Oh yeah, see it's it's the faculty dashboard. Let me see. Okay, so here's I think this is more like what you see, I hope. So you would select a topic, math, and then you would select a subject. And thank you for pointing out that it does say college algebra instead of intermediate algebra. The topics in college algebra repeat a lot of what we see in intermediate algebra. So anything that you ask will not bother the tutor, so you'll be fine. Then you click on Get Live Help. Okay, let's take a tour. It shows you the tools. Okay. I'm going to just say, hi, I am a teacher showing my students how to use your service. Okay, so you can use your mouse, or you can get a tablet for pretty cheap, like I carry around with me in the classroom, that you just literally plug in and it works from there, where you can draw. Let's see. Although I'm having trouble drawing right now. There we go. All right, so actually my mouse is working better than my tablet right now, but although that's hard to use. So. Oh, I know why. This particular tablet doesn't work with some plugins. The one that I carry around from class to class, let me tell you which one it is. It's called the XP Pen. It's very inexpensive. I think it was like $20, and it allows you to plug in without having to install a driver. And I find that it works on these web apps much better. So anyway, any other questions before we log off? Okay, so I think I'm going to log off, but remember, don't be a stranger. I want you to be successful, and I'm here to help. Have a good weekend, guys.